Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, let's look at some questions about empirical formula. So what is an empirical formula? The simplest whole number ratio of elements in a compound. And it just needs to be written as if it's a normal formula. To be honest, in order to understand what that statement means, it's easiest to look at quite a simple example. So if a substance has a molecular formula of C4H8, what is its empirical formula? So first thing to do is look at those two numbers, 4 and 8, and decide what is the largest number that those are both divisible by. So both 4 and 8 are divisible by 4. If I divide 4 by 4, I get 1. If I divide 8 by 4, I get 2, which means I have 1 carbon, C, and I have 2 hydrogen, H2. So my empirical formula for C4H8 is CH2. Okay, let's do a question for percentage by mass. So what is the percentage by mass of oxygen in magnesium hydroxide? I've given the formula there. Relative atomic mass of magnesium is 24, of oxygen is 16, and of hydrogen is 1. So first, let me think about my equation for percentage by mass. It's going to be the relative atomic mass of the element times the number of times that features in my particular formula divided by the relative formula mass times 100. So let's break that down for this example. My relative atomic mass, I'm interested in the oxygen. So that for my oxygen, well, I need to think about the fact that in that formula there, I've got OH in brackets and a 2 at the bottom. So my oxygen actually appears 2 times. So I've got 16 times 2, the number of times it features, divided by, and now for my relative formula mass of this magnesium hydroxide. 1 magnesium, so that is the relative atomic mass of 24, plus, and then I've got 2 oxygen and 2 hydrogen. So 16 plus 1, that's my oxygen plus my hydrogen's relative atomic masses, both of those multiplied by 2, and then times 100 on the end. And if I do it, I get 55.2%. Okay, let's have a go at finding the empirical formula of this compound. So I've got 3.1 grams of hydrogen, I've got 31.6 grams of phosphorus, and 65.3 grams of oxygen. I'm asked what the empirical formula of the compound is, and I have been given the relative atomic masses of those three things. So hydrogen 1, phosphorus 31, and oxygen 16. Now, we can remember this acronym to remember what to do, murmur. So my first M stands for mass, that R is relative formula mass. The next M is moles, and then finally that R is for ratio. And let's have our 3 elements as well, HPO. So first, I'm just going to fill in the masses that they gave me into this table. So 3.1 for H, 31.6 for P, and 65.3 for O. Now time to think about the relative formula masses here. So hydrogen, that is just 1. Phosphorus, I'm using my periodic table here, or my, well, actually it's given it to me in the question. 31, my relative atomic mass, and oxygen, that is 16. So now for the number of moles. Since I have this mass of 3.1 and my relative formula mass for hydrogen, or relative atomic mass for hydrogen, is 1, remember to find the number of moles, I take my mass and divide it through by either the relative formula mass or relative atomic mass. So that gives me 3.1 for hydrogen. Do the same for phosphorus, that gives me 1.02. And I do the same for oxygen, but this time I've got this 65.3 divided by 16 gives me 4.08. So then my ratio is have a look at what the smallest number is, and remember, divide these number of moles by that smallest number. 3.1 divided by 1.02 is 3, 1.02 divided by 1.02 is 1, and 4.08 divided by 1.02 is 4. So that's the ratio that these three elements appear in. So I've got H3, P1, and O4, and I'm done. A substance contains 1.244 grams of carbon and 0.26 grams of hydrogen. What is the empirical formula of the compound? We're given the relative atomic masses. So murmur again, let's get our table going. Mass, relative formula mass, moles, ratio. And let's get a column for my carbon and my hydrogen. We've been given both the masses, so let's pop those into the column, and we've also been given relative atomic masses, so let's put those in my relative formula mass section 12 and 1 as well. So let's calculate the first thing we can calculate, which is the number of moles of these two elements. So carbon, remember you're doing your mass divided by your relative formula mass, and it gives you 0.103 moles. And hydrogen, mass 0.26 divided by 1, relative formula mass, gives me 0.26. So what ratio are they in? Well, remember we take the smallest one here, 0.103, and divide both of the mole numbers 3 by that number. And we get 1 for my carbon, but when you do 0.26 divided by 0.103, we get 2.52. So not a whole number there. So we're not in a proper whole number ratio yet. That is 2.5, and so roughly, okay, that's 2.5, which is 2.5. So remember, we then take that bottom number of our fraction and we multiply our ratios by that. So 1 times 2 is 2, 2.5 times 2 is 5, and that is our smallest number ratio. So we've got 2 carbon, 5 hydrogen, C2H5.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, some tips and tricks for this section. So yeah, remember not to round too early. I would keep maybe at least 3 significant figures until you are confident of your ratio, okay, because it can get a bit muddled if you round too early. Always quote your answer as a proper formula, not just a ratio. So don't just say, oh, the carbon and hydrogen ratio 2:5. You should write C2H5 for my previous example. You won't be given the table in the exam, so you need to remember murmur and feel confident setting up that table. And actually it's a bit tricky because obviously there are 2 M's there and 2 R's, so remember which way round it is. Also, you need the stuff that we did before, which is being able to calculate moles from masses in order to do this. Finally, if you can't get to an answer, clearly show how you're working out the number of moles for each element, and that will mean you pick up a few marks. So don't just stop and not do anything. Try and figure part of the question out to gain as many marks as possible.